So parallelograms, we already know everything that we just talked about them. So I'm just going to list them real. If you don't want to rewrite this down, that's okay. So I'm just going to, just so we have it on one page. Parallelogram properties. You have the two pairs of parallel sides. Two pair parallel sides. You have two pairs of opposite sides congruent. You have any two consecutive angles supplementary. You have opposite angles congruent, and diagonals bisect. Okay, so what we're going to do today is basically take these fun facts, and we are going to apply them to some problems, and we're going to have some equations that we have to write, so we're going to throw some algebra into the mix here. Okay, so let's start off easy. I know, for example, like if I'm looking at the second bullet here, you're going to have two pairs of opposite sides that are congruent. So last night was super easy. If you were given a parallelogram, which you were on everything, okay, so I'm going to put a star here. All shapes are parallelograms. So now we know. Okay, so it is official. Every shape that I'm drawing on here is going to be a parallelogram, so we don't have to keep saying it. All right, so yesterday I said, okay, well, if this is 10, then what's this? And you just told me, okay, well, it's 10. Well, today we're going to mix it up a little bit. We are not just going to have them be straight numbers. I'm going to give you some expression for this side. So instead of just being x, maybe I do something like, say it's, I don't know, 2x plus 2. And you now need to solve for x. Well, if you know that the two pairs of opposite sides are congruent, that means that my equation is just going to be 10 equals this, and then I just solve that equation. That's not bad, right? So take a second, solve for x for me in this.
4.
What'd you say?
4.
4, it's correct, right? This one's nice and easy. So I'm just going to take 10, set it equal to the 2x plus 2, and then solve from there like I normally would. So yes, absolutely, I get 4. All right, let's try something else. What if I gave you this? So say I gave you this parallelogram and I told you, I don't know, what if I gave you that? Let me zoom in a little bit so you can see it better. So these are angle measurements. So one angle here is 2x plus 10, and this angle here is 30. So you need to sort of take a step back and ask yourself, okay, well, I have to write an equation to solve for x. And according to my list up here, sorry, I'm just going to move away from it real quick. So if I look at the deal with the angles, I really have two choices that deal with angles. Any two consecutive angles are supplementary, or opposite angles are congruent. So you kind of need to determine, well, do I have consecutive angles or do I have opposite angles? So what do you have in this case? Are these angles opposite each other or are they consecutive?
Opposite.
You sure?
Oh, consecutive. I have the answer.
What is it?
70.
70, you say. I agree. These are two angles right in a row. As I'm going around my parallelogram, right? So, and it doesn't matter what, if you go clockwise or counterclockwise. Here, I hit the 30-degree angle. The one right after it is this 2x plus 10. So that means that they are consecutive, one right after another. So if I have two angles, one right after another, that means that they are consecutive. And according to these fun facts right here, they are going to be supplementary. So remember what that means. That means that these two together are going to add to be 180. So that's my equation. They are not equal to each other in this case. I'm going to add 2x plus 10 plus 30, and all together it gets me to 180. Right? And now I'm just going to solve this equation like I normally would. 2x plus 40 equals the 180, and then solve, solve, solve. So those of you that got 70 are correct. If you got 10 as your answer, you set those two angles equal to each other, and that's not true. They're not equal to each other. Will they ever be equal to each other? If you have opposite angles, sure. So what if we did something like this? I really need like a template of parallelograms. I don't know why I'm so bad at drawing them. I get really good at drawing circles when we talk circle stuff, but I don't know. I can't do parallelograms very well. All right, what's going to be the deal with these two? How about this is, oh, I don't know. How about your 3x plus 5, and you are 2x plus 20? Yeah, go for it. Nothing's drawn to scale. Let me zoom in so you can see that better. So remember, all of these shapes are parallelograms. So go ahead and solve for x for me and see what you get. Feel free to send me your answer in the chat. Kira, that's right. Okay, so be careful here. These two angles are not consecutive, right? It's not one after another. As I go around, you see right after this one would be this one, and there's nothing there. These two are across from each other. These are opposite angles. So if you recall from up here, if you have opposite angles, what's the deal? They're equal to each other. So the key today is knowing whether I'm going to add the angles together and set it equal to 180, or am I just going to set them equal to each other? In this case, they're equal to each other because those are opposite angles. So my equation should just be 3x plus 5 equals 2x plus 20. All right, so double check that you have that equation or an equivalent equation. And now I just need to solve. I have x's on both sides, a 3x and a 2x. I need to get them together. So I would probably subtract 2x from both sides just to keep the x's positive. So now I've got x plus 5 equals 20, and then just minus that 5 from both sides. So I get x equals 15. Yep. So if you gave me 15 as your answer, you are correct. I'm going to ask you a bonus question right now. What? If x is 15, what's the value of y over here, that angle? Huh. I guess I should figure it out myself to see if you're right or not. So take a moment. What do you think angle y would have to be if x is 15? Remember, nothing is drawn to scale.
50.
So I'm seeing some answers in the, oh, I just got the, Olivia, that is the first right answer. I'll give everybody another minute. So I'll give you some hints. It is not 165. Mark, that's right. Yes, so 130 is the right answer for y. What? How? Here's how. If you know that x is 15, x is not the measure of this angle. This angle is 3x plus 5, right? So you'd have to take x and plug it back in and see what you get for this angle. So 3 times 15 plus 5 means that this angle actually measures 50. Right? Because 3 times 15 is 45 plus 5 is 50. So now if you know that this angle is 50, this one that I marked y, they are consecutive. So these two have to add up to be 180. So that's how you know y has got to be 130. Remember, nothing is drawn to scale. So I know this one looks like they should be swapped, but it doesn't matter. You always go off of numbers, not looks. So yeah. Y would be 130. How fun. Okay. So let's try another one. I'll stick one more over here. Okay, if this thing is a parallelogram, go ahead and do this one for me. Solve for x, please, everybody. Feel free to send me your answer in the chat when you get it. Chase, that's right. Olivia, that's right. Kira, that's right. Elizabeth, that is right. Okay, good. So it seems like you guys are comfortable with setting up the equation, knowing that it's either going to be equal or they're going to be supplementary. Since these are two angles right in a row, they're consecutive. So your equation should have looked like this: 7x plus 15 plus 13x plus 5. Together is going to get me to that 180. All right, so you would not set these two angles equal to each other because they're not opposite of each other. So if it's one right after another, you add together, set it equal to 180. And now I'm just going to solve. 7x and 13x is 20x. 15 and 5 is 20. And then I just solve like I always do. So looks like everybody that got 8 as their final answer, and it looks like most of you did that shared your answer with me. So are we ready to step it up a notch? I thought so. All right, so now we're going to bring in, we're going to talk now more about the diagonals. So remember, our last fun fact in our list here was that the diagonals bisect each other. So we're going to use that coupled with some expressions to write some equations and solve. So let's just flip the page here. So again, all of our shapes are parallelograms here. So let's start off with one nice and big. It's especially bad that I struggle with parallelograms because you probably can't see them, but there's like lines on the page. See them? See those little dots? So there is a grid for me to follow, and I can't ever seem to do it right. See them? They're there. Anyway. Okay, so you have this parallelogram. I'm going to go ahead and draw in the two diagonals. Oh dear. There's that one, and here's that one. Okay, and we'll put a point E in the middle. All right, let's start off easy, and then we'll crank it up. Okay, try this one for me. Solve for x, please. Yes. Olivia and Kira, those are both right. I'll give you guys another minute to send me some more answers because I only have 2 so far. Come on, nobody else has an answer? I know you do. Elizabeth, correct. So remember the deal with the diagonals. Yes, they bisect each other. So that just means that these two pieces have to be equal. AE and EC are equal to each other. So this one's a pretty easy equation. I'm just going to literally write 5x minus 3 equals 4x plus 9. And then I solve from there. So you probably got 12. And if you did, you are correct. You can always go back and check this, right? That's part of one of the things that's so great about math. Once I realize that x is 12, I can plug it in and see if it really does work. So 5 times 12 is 60 minus 3 is 57. And then if I go over here, 4 times 12 is 48 plus 9, 57. So I get the same value on each side, so I know that I'm right. All right. Now we're going to make this a little bit more complicated. What if I told you? Let's see how I want to do this. You know what? I'm just going to draw a new one because I want you to have it nice in your notes. Okay, this time I am going to tell you that BD, the whole thing, is 8x. And I am also going to tell you that BE, just that piece, is x plus 6. So take a minute and see if you can come up with an equation that will work here. So x plus 6 is just the length of BE. And then BD, the whole thing, is 8x. Try it. Once you get your value for x, plug it back in and see if it makes sense. Feel free to send me your answer for x when you get it. Haley, that is correct. Very nice. Elizabeth, correct. Okay, so let's kind of work our way through this one. You're not going to set these two equal to each other because they're not, right? BE is just this piece. There's no way it could be equal to the whole thing. What is true? Oh, okay. I've been asked to wait. I will wait. Feel free to send me your answer in the chat if you want me to let you know if you got it right or not. Okay, so they are not equal to each other, right? X plus 6 is certainly not equal to 8x. What is true, however, is that BE and ED are equal to each other, aren't they? Right? Because if the diagonals bisect each other, so this piece here from B to E is always going to be the same as the piece from E to D. So this is, we have done this before, just we did it with angles, like the bisecting angles and other things like that. If this piece is x plus 6, that means this piece here is also x plus 6. And now you can write an equation because you know that this and this together get you the whole thing. So that's going to be what my equation looks like. I'm going to take x plus 6, and I'm going to add the other x plus 6 to it. So I want 2 of those, and it's going to equal the whole big thing, which is 8x. There's an equation that will work for me. All right. You might have gotten the same thing by taking 8x. I wonder if anybody did this. Did anybody take 8x and divide it by 2 and do 4x? Did anybody do that? You can do that and you will still get the right answer. The thing that I caution you on is what happens when that's not a nice thing to divide, right? What if it was 7x? Now you've got to deal with a fraction or a decimal. What if it's like 7x plus 9? Now you're going to have, you know what I mean? So I would advise you against taking half of this. I would always just double this, so you have 2 of them, add them together, and set it equal to the whole thing. And then you don't have to worry about decimals and fractions. This time it worked out because 8x is nice to cut in half, but it won't always be the case. So now I'm just going to solve it. X and x is 2x. 6 and 6 is 12. All right, so now I just want to get my x's together, so let's minus 2x to the other side. and I just divide by 6. So this time, yeah, I get 2. That's it. And what's so great about this is you can check it. If x really is 2, let's see. 2 plus 6 means that BE has a length of 8. Obviously, that's also 8. And then let's see. 2 times x would be 16. Yeah, that works because 8 and 8 should get me to 16, and it does. So cool. All right, let's try another one like this. I'm going to try and trick you, so be ready. All right, let's do. Give me a second. I got to pick nice numbers. Oh, yeah, I know what I'll do. Oh, that doesn't work out great. Hold on, let me do it this way. All right, I think I got some numbers. Okay, so let's do this. DB, the whole thing. We're going to have that be negative 8x plus 4. Okay, so that's that whole length. And then I'll tell you, oh, I forgot to put, that's point E. ED, let's have that one as, I think I got this right, negative 6x minus 4. Let me make this a bit darker. All right, try that. Olivia, that is correct. Sorry, it keeps like blinking out on you. I'm trying to, if I click on any other screen on this, sorry, I'm trying to post your assignment real quick. This is B block. Okay, so let's go through this one and see if we can figure out the right answer here. You should have gotten -3. Oh, and of course it freezes on me. -3 is going to be your right answer here. Okay, so I'm catching back up in the chat. Yes, Haley, I see the -3. No, so you're not going to take the absolute value here. Remember, you can't have a negative diagonal, right? The length of the diagonal can't be negative. But even though x comes out to be -3, when you plug it back in, nobody's negative. Because if you do, think about it, if you do -8 times -3, now it's a positive 24 plus 4, you get 28, and that's totally fine. Same thing happens down here. -6 times -3 is now a positive 18, minus 4 is still 14. So you would have an issue if one of the lengths ended up being negative, but they're not. So I tried to throw you for a loop. Don't let me. All right, so again, I have, if this is -6x minus 4, so is this. They're exactly the same. So my equation is just going to be -6x minus 4, and then another -6x minus 4. So I'm going to add to that -6x minus 4. So I have those two. And then together they equal -8x plus 4, the entire thing. Okay, so now I have my equation. Now I'm just going to solve it. -6x and another -6x is a -12x. And then -4 is a -8. -8x plus 4. And now I'm just solving like I always do. So I would add 12x. I would minus the 4. So I have -12 equals 4x divided by 4 divided by 4. So yeah, if you came out with a -3, you're spot on. And it really does work. It checks if you plug it back in. Let's pop it into this red section here. So -6 times -3 is positive 18 minus 4, means that that piece is 14. Okay, so that means when I plug in -3 up here, if that's 14, then this should come out to be 28, because 14 and 14 is 28, right? Let's see. So -8 times -3 is a positive 24 plus 4, 28, just like we were expecting. So now I know that I have it right. So -3 is the right answer, and we're good. Okay, so that is everything that I wanted to cover from the homework. I did just post your assignment, so if you feel comfortable and you're ready to go for it. If you are like, I have no idea what the heck you're doing, lady, I will do a few of them with you. Let me just, here it is. View presentation. Let me just share this screen. Oh, it's chilly in my house. It's chilly in my house every day because I'm too cheap to turn up the heat. It's so expensive. So I started you off easy. Obviously, yeah, that's just 9. You did that yesterday, no big deal. Okay. But then you're going to hit ones like this where you're like, oh, well, I need to think about this one. So stop and ask yourself, well, what do I have? Oh, those are angles. What's the deal with the angles? The angles are going to be, if they're one right after another, like these two are, those are consecutive angles. So that means that they will be supplementary. Okay, so that's the ticket here. So you need to be able to look at this, recognize, oh, those are two angles, one right after another. So that means that they are going to have a sum of 180. So that is how you would set this one up, and then obviously solve it, and whatever you get, right? Now be careful though, because you don't always just add them together and set it equal to 180, because you might get one like this. These are opposite angles. Opposite angles are not supplementary. They are equal. So this time you would just set them equal to each other. 125 equals the 17x plus 6. And then just solve from there. Okay, so be careful. It's not one set thing. So you got to stop and think, well, what are these? Are they going to be equal, or do I add them together, set it equal to 180? All right, and here, okay, these are the sides now. So you know sides are always equal, so that should be pretty straightforward. So be careful. Ooh, that one's a fun one. And then you're going to hit the diagonals, okay? So be careful with the diagonals. Make sure you're paying attention to what information they give you and what information you, so that's going to determine how you set up your equation. So if I look at this one, SE is 7 and EU is 6x plus 1. So I know that the diagonals are getting cut in half. So that means that those two little pieces are equal to each other. So my equation for this one is just 6x plus 1 equals 7. Right? If they give me just this piece and just this piece, they're always equal to each other. And now I can just solve, and that should be pretty easy. Now, be mindful, though, because sometimes they're going to give you, yeah, here's one where they give you a piece and then the whole diagonal. So these are the ones that you got to kind of slow down and be careful on. So VS is going to be 20x. Okay, that's fine. But then VX, the whole thing, that's 41 minus, or 41x minus 1. Okay, so what do? Well, remember that the two little pieces are the same. So that one's 20x, this one's 20x. And now I can write an equation. 20x and another 20x all together is going to get me that 41x minus 1. And now I have an equation that I can solve. All right, so I'll just do this one out. Why not? 20x and 20x is 40x. 41x minus 1. And then I would just minus 41x from both sides, I guess. So negative x equals negative 1, which means that x is just a positive 1 in this case. How cool! And if you plug 1 back in, it should work out. Okay, so, and I think that's it. Yes, okay, so give these a try. Does anybody have any questions right now? All right.